Hello everyone. Welcome to Shark MP200 Technical Training. In this part of the video, we will be looking at the mechanical and electrical installation procedure in MP200 high-density metering system. So, let's get started with the mechanical installation and maintenance, which includes some steps to complete this procedure. Here, we'll firstly talk about the MP200 unit dimensions. If you look at the drawing here, you will notice the MP200 unit front dimensions, which are displayed in inches, and in millimeters, which are shown in square brackets. Similarly, in another drawing you will notice the MP200 unit side dimensions displayed in inches and millimeters in brackets. Now, let's go ahead and look at the process of mounting the MP200 unit. The MP200 unit is designed to mount against any firm, flat surface. Use a number 8 screw in each of the 4 slots on the flange to ensure that the MP200 unit is installed securely. For safety reasons, mount the MP200 unit in an enclosed and protected environment, such as in a switchgear cabinet. Install a switch or circuit breaker nearby. Label it clearly as the MP200 unit's disconnecting mechanism. The recommended tools for MP200 unit installation are number 2 Phillips screwdriver, 1 4-inch 0R 0.25 nut driver, socket, box, or open-end wrench, wire cutters. The MP200 unit is designed to withstand harsh environmental conditions. However, it is recommended you install it in a dry location, free from dirt and corrosive substances. Before proceeding to cleaning the MP200 unit, it is important to keep in mind that do not clean the unit with power applied. Always disconnect the power from the MP200 metering system before following the cleaning procedure. Now, we move on to the procedure of cleaning the MP200 unit. The first step is to wipe the MP200 unit with a dry cloth. If stains or other material cannot be removed with a dry cloth, slightly moisten a cloth with a consumer window cleaner and use this to remove the stains or other material. Immediately wipe the unit down with a dry cloth to eliminate remaining moisture. The unit must be completely dry before being re-energized. Dust may be blown off using room temperature compressed air at a maximum of 20 psi. So, this is pretty much everything we need to see in the mechanical installation. Next, we will look at the electrical installation procedure step by step. Before beginning with the procedure, there are certain considerations which need to be considered when installing the MP200 metering system. The first one is, installation of the MP200 metering system must be performed only by qualified personnel who follow standard safety precautions during all procedures. Those personnel should have appropriate training and experience with high-voltage devices. Appropriate safety gloves, safety glasses, and protective clothing is recommended. The second one is, during normal operation of the MP200 unit, dangerous voltages are present in many parts of the unit, including terminals and any connected CDs or current transformers, NPDs or potential transformers, all I/O modules inputs and outputs and their circuits. The third consideration is that all primary and secondary circuits can, at times, produce lethal voltages and currents. Avoid contact with any current-carrying surfaces. The fourth one says that do not use the MP200 metering system or any I/O output device for primary protection or in an energy-limiting capacity. The MP200 metering system can only be used as secondary protection. The fifth one is, do not use the MP200 unit for applications where failure of the MP200 unit may cause harm or death. The sixth one is, do not use the MP200 unit for any application where there may be a risk of fire. All MP200 unit terminals should be inaccessible after installation. Coming to the last one, Do not apply more than the maximum voltage the MP200 unit or any attached device can withstand. Refer to MP200 unit and/or device labels and to the specifications for all devices before applying voltages. Do not HIPOT dielectric test any outputs, inputs, or communication terminals. Now, EIG recommends the use of fuses for voltage leads and power supply, and shorting blocks to prevent hazardous voltage conditions or damage to CTs if the MP200 unit needs to be removed from service. One side of the CD must be grounded. Also note that the current inputs are only to be connected to external current transformers provided by the installer. The CTs shall be approved or certified and rated for the current of the meter used. A few more important things to note are if the equipment is used in manner not specified by the manufacturer, the protection provided by the equipment may be impaired. There is no required preventive maintenance or inspection necessary for safety. However, any repair or maintenance should be performed by the factory. In addition, an equipment disconnect device is to be taken into consideration. A switch or circuit breaker shall be included in the end-use equipment or building installation. The switch shall be in close proximity to the equipment and within easy reach of the operator. The switch shall be marked as the disconnecting device for the equipment. Now, we move on to the next section, which is the MP200 ground connection. In the image, you will clearly notice the ground terminal, or the ground lug, which is already provided in the MP200 unit. This ground terminal should be connected directly to the installation's protective earth ground. The AWG number 12 by 2.5 square wire should be used for this connection. After this, there are voltage and power supply connections. Voltage inputs are connected to the bottom of the MP200 unit via wire connectors. The connectors accommodate AWG number 12, 26 by 0.129, 3.31 square. Talking about the voltage fuses, EIG recommends the use of fuses on each of the sense voltages and on the control power, even though the image here does not show them. Use a 0.1 ampere fuse on each voltage input rated for 600 volts. Use a 3 ampere slow blow fuse on the power supply rated at 500 volts. EIG offers the CP panel meter protective fuse kit, which can be ordered from our website. After this, we move on to the next section, which is wiring the monitored inputs currents. The cables to the current inputs shall be rated for a minimum of 600 volts AC and 10 ampere 14 AWG copper cable, cross-sectional area of 2.08 square. Mount the current transformers as close as possible to the MP200 unit's meters. In this table, you can see the maximum recommended distances for various CD sizes, assuming the connection is via 14 AWG copper cable. Here also, it's important to note that do not leave the secondary of the CD open when primary current is flowing. This may cause high voltage, which will overheat the CD. If the CT is not connected, provide a shorting block on the secondary of the CD. EIG highly recommends using shorting blocks to allow removal of the MP200 unit from an energized circuit, if necessary. We'll see it later in this video. EIG recommends using a 3-phase shorting block for every 3-phase load. An example of that shorting block is the EISB6DC, which you can see here. It can be ordered from our website. You will need 8 shorting blocks for the 8 3-phase circuits. Shorting blocks allow you to short an installed current transformer so that the meter can be uninstalled, if necessary, for servicing. This is a highly important safety feature. It is important to maintain the polarity of the CT circuit when connecting to the MP200 unit's meters. If the polarity is reversed, the meters will not provide accurate readings. CT polarities are dependent upon correct connection of CT LEDs and the directions are facing when clamped around the conductors. Now, let's go ahead and look at the various electrical connections for MP200 units meters, which now support delta connections as well as Y. There are different connection diagrams which we'll see later in this video. The users can select the one which best suits their application needs. Please make sure to maintain the CT polarity when wiring. The first one which we are going to see is 3-phase, 4-wire Y service direct voltage and 3 CD connection for metering 8 3-phase loads, MP200Y. The diagram clearly shows all the connections and wiring in the MP200 unit. In this, a few points are to be noted that all CDs must have one side grounded to reduce shock hazard. You must order the MP200Y unit for the 3-phase operation. EIG highly recommends using shorting blocks like the ISB6DC so that the meter can be removed from service while the CD is energized. 8 shorting blocks should be used for all 8 3-phase circuits. Next diagram shows the 3-phase, 4-wire Y service with 3 PD voltage and 3 CD connection for metering 8 3-phase loads, MP200Y. Here also, the same things are to be noted as earlier that all CDs must have one side grounded to reduce shock hazard. You must order the MP200Y unit for the 3-phase operation. EIG highly recommends using shorting blocks like the ISB6DC so that the meter can be removed from service while the CD is energized. 8 shorting blocks should be used for all 8 3-phase circuits. After this, we have the next diagram shown is 3-phase, 3-wire delta service with direct voltage and 2 CT connection for metering 8 3-phase loads, MP200Y. Here also, the same points are to be noted as earlier. Moving on to the next diagram, that is single-phase, 2-wire service with direct voltage and 3 CD connection for metering 24 single-phase loads, MP200S. Here, you need to note that all CDs must have one side grounded to reduce shock hazard. You must order the MP200S unit for single-phase 2-wire operation. EIG highly recommends using shorting blocks like the ISB6DC so that the meter can be removed from service while the CD is energized. Next diagram which is shown here is single-phase, 3-wire service with direct voltage and 2 CD connection for metering 8 single-phase loads, MP200Y. Here also, note that all CDs must have one side grounded to reduce shock hazard. You must order the MP200Y unit for this operation. EIG highly recommends using shorting blocks like the ISB6DC so that the meter can be removed from service while the CD is energized. A higher density connection is available using the single-phase version of the meter. The difference is that the higher density uses a single CD for both legs of a 3-wire system. After this, we move on to the next diagram shown as single-phase, 3-wire service with direct voltage and 1 CT connection for metering 24 single-phase loads, MP200S. Note that all CDs must have one side grounded to reduce shock hazard. You must order the MP200S unit for single-phase operation. EIG highly recommends using shorting blocks like the ISB6DC so that the meter can be removed from service while the CD is energized. Now, the next section is removing the MP200 unit from service, reinstalling the MP200 unit. Before beginning with the procedure, there are a couple of warnings which we need to consider. Before attempting any work on the MP200 unit or associated components, all power must be removed and all circuits de-energized. Verify the de-energized status of all the circuitry with appropriate portable measuring equipment. If the MP200 unit was directly wired to the X without a shorting block, as disclosed in this manual, then all the electrical primary circuits must be shut down prior to removing the meter. Failure to do so could result in possible high voltage on the open CT terminals. Then, we proceed to removing the MP200 unit using the EISB6 DC shorting block. Note that this procedure uses the EISB6 DC shorting block. For shorting blocks other than that, we'll look at the procedure later. We'll also look at removing the MP200 unit using a shorting block other than the EISB6 DC. Coming back to the procedure, the first step is to verify that all circuits are de-energized and locked out. Then, all shorting blocks shall be wired as per the wiring diagrams shown here. Third step says that all shorting blocks are equipped with 4 brass shorting screws stored in the 4 corners of the base, which you can clearly notice in the image shown. Now, the important thing is that if all 4 brass shorting screws are not on the shorting blocks, do not continue until replacements are obtained. The fourth step is select one of the shorting blocks. Then, remove one of the brass shorting screws from the plastic base and place it through the brass shorting bar over one of the grounded terminals and tighten max torque of 16.2 in pound, 1.8 Nm. Verify that, when tightened, the screw head is in full contact with the brass bar. Next, remove another brass shorting screw and place it through the brass bar over an ungrounded lead of a CD and tighten max torque of 16.2 in pound, 1.8 Nm. Verify that, when tightened, the screw head is in full contact with the brass bar. If necessary, remove another brass shorting screw and place it through the brass bar over an ungrounded lead of the second CT and tighten max torque of 16.2 in pound, 1.8 Nm. Verify that, when tightened, the screw head is in full contact with the brass bar. If necessary, remove another brass shorting screw and place it through the brass bar over an ungrounded lead of the third CT and tighten max torque of 16.2 in pound, 1.8 Nm. Verify that, when tightened, the screw head is in full contact with the brass bar. If necessary, repeat steps 4 through 8 until all CDs are shorted. Then, mark or record the location of the current input wires on the MP200 unit. Disconnect all current input wires from the MP200 unit. Remove all connectors from the MP200 unit. Remove the ground connection from the stud on the MP200 unit as shown in the image. Then, remove the 4 mounting screws holding the MP200 unit in place. Finally, remove the MP200 unit. Once the MP200 unit is removed, it's time now to reinstall it using the EISB6 DC shorting block. For that, place the MP200 unit in the desired location over the mounting holes. Then, insert and tighten all 4 mounting screws. Now, connect the ground wire to the stud on the MP200 unit and tighten the nut to 8.8 in pound 1 Nm as shown in the image. Connect the current inputs to the MP200 unit as per the location marked on the wires or recorded, which you can notice in the image here. Then, tighten nuts to 8.8 in pound 1 Nm. Insert all connectors into the MP200 unit. Select a shorting block and remove the screws shorting the ungrounded side of this and screw them into their storage location in the corner of the block, max torque of 1 in pound, 0.11 Nm. An important point here is that the screw that is grounding the brass bar should be removed last and also stored on the block. If necessary, repeat the previous step until all shorting blocks are returned to their operating configuration. Apply power to the meter and energize all circuits. Verify correct operation of the MP200 unit. Now, before we conclude, let's also quickly check out the process of removing and reinstalling the MP200 unit using a shorting block other than the EISB6 DC. So, proceeding with removing the MP200 unit, verify that all circuits are de-energized and locked out. All shorting blocks shall be wired as per the wiring diagrams in this manual, with one side of each CT at ground potential. Using the shorting blocks, short the ungrounded side of all CTs to ground. Mark or record the location of the current input wires on the MP200 unit. Disconnect all current input wires from the MP200 unit. Remove all connectors from the MP200 unit. Remove the ground connection from the stud on the MP200 unit as shown in the image. Then, remove the 4 mounting screws holding the MP200 unit in place. After removing, begin reinstalling the unit by placing the MP200 unit in the desired location over the mounting holes. Then, insert and tighten all 4 mounting screws. Connect the ground wire to the stud on the MP200 unit and tighten the nut to 8.8 in pound 1 Nm as shown in the image. Connect the current inputs to the MP200 unit as per the location marked on the wires or recorded. Tighten nuts to 8.8 in pound 1 Nm. Then, insert all connectors into the MP200 unit. Remove the short from all the ungrounded sides of all the CTs. Apply power to the meter and energize all circuits. Finally, verify correct operation of the MP200 unit. In this way, you can easily perform the installation of MP200 unit in a safe and efficient manner. So, this concludes our video. I hope you understood the mechanical and electrical installation procedure completely. See you next time with some more useful stuff related to energy meters. Until then, keep learning, and thanks for watching this video.